Good day. Welcome to this session where we're going to look at hybridization, sigma bonds, and also pi bonds. But before we can go any further, let's understand what hybridization means. So when you're talking about hybridization is just the mixing of the atomic orbitals in order to form new hybrid orbitals. So we are saying it is just mixing atomic orbitals to form new hybrid orbitals. So this is basically what hybridization is all about, just the mixing of atomic orbitals in order to form hybrid orbitals. And the reason why we need to mix these atomic orbitals is so as those hybrid orbitals can participate in bonding. Okay, so that is the reason. Now let's also look at the way in which you can illustrate or in which you can show hybridization. Let's say you have a certain compound. This is ammonia. It has a lone pair there. Now let's say you've been asked that what is the hybridization of this compound ammonia. So to identify or to show the hybridization of this compound ammonia, you need to count how many things are attached to this ammonia. We can see that there are 3 hydrogens attached to this ammonia, and we have how many lone pairs? There is just 1 lone pair, because there are 3 things attached to this 2 hydrogen rather attached to this nitrogen, and also the lone pair which is just 1. When we've been asked to show the hybridization of this nitrogen in the compound ammonia, we are going to say sp3 because there are 4 things attached. So how do you know the number of things attached to a certain element in a compound? So you just count them. So to show now the hybridization, for example, when you have 2 things attached to a certain compound, the hybridization will be sp. When you have, let's say, 3 things attached to that compound, the hybridization will be sp2. Okay, when you have 4 things attached to that compound, the hybridization will be sp3. So that is the hybridization of nitrogen in ammonia. Let's look at another example whereby we have this compound. This is methane. Then you've been asked what is the hybridization of carbon in methane. So the hybridization of this carbon in methane, you can see that carbon has 4 attachments of hydrogen rather. So because it has 4 attachments of hydrogen in methane, we're going to say the hybridization is sp3. Let's look at another compound. Let's say you have carbon dioxide or carbon dioxide. Then what is the hybridization of this carbon in carbon dioxide? So you can see that there are only 2 things attached to carbon, this oxygen there and that's oxygen. Okay, because there are only 2 things attached, The hybridization of carbon in this compound is sp. So basically this is the knowledge you need to understand about hybridization. We're going to do an exam question at the end of this session. So now let's look at sigma bonds and pi bonds. What are sigma bonds and what are pi bonds? So when you're talking about sigma bonds are just bonds which are formed by head to head overlap of atomic orbitals. So we are saying they are bonds formed by head to head overlap of orbitals. So those are what are known as sigma bond, and we must understand that sigma bond are simply covalent bonds. Sigma bonds are covalent bonds. So now let's look at the representation of this sigma bond. So they are represented by this symbol, a sigma. Okay, they are covalent bonds, and we understand that since they are covalent bonds are the strongest bonds. Okay, covalent bonds are stronger than the ionic bond, they are stronger than the hydrogen bond, they are stronger than the van der Waals bonds or interactions rather. They are stronger than other bonds, the hydrophobic bonds. Okay, they are stronger than disulfide bonds. Covalent bonds are the strongest. Okay, now let's look at the pi bonds. So they are represented by this same common symbol we know in mathematics called the pi. So these pi bonds, they are the bonds formed by, they are covalent bonds rather, formed by side to side overlap of atomic orbitals. So these are formed by side to side overlap of atomic orbitals. So this is what are known as the pi bond. Now let's look at the difference between these two. The difference between these two bonds. So we need to understand that one of the difference between pi bond and sigma bond. So when you have sigma bond here and pi bond there, sigma bond are the first one to be formed. Okay, but these pi bonds, they are formed after sigma bond. They are formed after sigma bonds. Okay, first ones to be formed, but pi bonds. So it is very important that we appreciate that sigma bonds are the first one to be formed even before the pi bonds form. Then excuse me, the other difference between this sigma bond and the pi bonds is that the sigma bonds, these bonds are formed by head to head overlap, as I mentioned in the definition. They are formed by head to head overlap of atomic orbitals. But when you're talking about the pi bonds are formed by side to side. Okay, they are formed by side to side overlap. So these are formed by side to side overlap of atomic orbitals, but the sigma bonds are formed by head to head overlap. And between the two, we can compare the strength. Okay, when you have sigma bonds here and the pi bonds there, these are much stronger. Okay, much strong, but these are less strong. The pi bond are less strong because the overlap which is formed is not so much strong or effective, but the sigma bonds are much stronger because the overlap which is formed is so much effective. It is so much strong. So we need also to understand that. We can also talk about the rotation. So when you have the sigma bond and the pi bond, the sigma bond allows rotation. Okay, these ones allows rotation, but the pi bonds, these do not favor rotation, do not allow rotation. And the reason they don't allow rotation is very simple. This is because the atomic orbitals, they form the parallel connection. Okay, they are bonded in a parallel manner, or the distribution is in a parallel manner. No wonder these do not favor or allow rotation. So where can you find now the sigma bond and the pi bond? So this is what we are yet to talk about. So when you have a single bond, in a single bond, always there is one sigma bond. In a single bond, there is one sigma bond, and we don't have any pi bond in a sigma bond. But when you talk of a double bond has one sigma bond and it has one pi bond. When you talk of a triple bond, in a triple bond there is one sigma bond and two pi bond. So what do you need to understand here? The point you must take home here is that always in any bond, whether a single bond, rather a double bond or a triple bond, there is always a sigma bond. There's always one sigma bond, but the pi bond varies depending on the type of bond. When you have a single bond, there's no pi bond. When you have a double bond, there's just one pi bond, and when you have a triple bond, that's when you can have two pi bonds. So this is very important for us to appreciate, because we shall apply this concept when answering exam questions. So now let's look at exam questions. How can you apply this concept in answering exam questions? So let's say you have a question like this one. Refer to this compound, which is like this. So this is the compound we have. We have a double bond there. Okay, so this is the compound we have. Then the question is asking us to find the total number of sigma bond and pi bonds present. So we are finding the sigma bond and the pi bonds present in this compound. And the other thing is to find the hybridization of carbon and nitrogen, including also oxygen. So the other thing is to find hybridization now. Hybridization of carbon, nitrogen, and oxygen in this compound. So let's get into it. So let me go to the next slide. Okay. So the compound is like that, but in this manner, the way it is drawn here, in a skeletal manner, you cannot know the bonds involved, because at each and every corner there is a carbon atom. But in this way, you cannot determine the number of sigma bonds, the number of pi bonds, the way it is drawn. So you need to interpolate this diagram. So as we're going to draw, you can see that this is looking like how many sides does it have? 1 2 3 4 5 6, like an hexagon, so made of carbons. Okay, so we have carbon there, and just one thing, there's a double bond there, and also there, and also there. So the head skeletal part looks like a structure of benzene, but this structure is attached to nitrogen and hydrogen, bonded also to oxygen. So let's interpret this. So we have carbon there, and there's a double bond, mind you, there. Then we have carbon this side, we have carbon, okay, like this. It should be like that. So how many carbons? There are 6. Okay, so there's a double bond there, there's a double bond here, and there's a double bond there. Then we have nitrogen. Okay, nitrogen, we have hydrogen there. Then this nitrogen, there should be, is attached to oxygen. Okay, so it's attached to oxygen, but it's attached to, in fact the diagram here had missed at one point here. There should be a corner. So actually it should be like this. Okay, so here, so it is like that. There's a single bond, then there's a bend here like that. Then there's oxygen, then there's like that. Okay, so this is the question which was asked. So now let's interpret this. Okay, so the part, let me get rid of this, then I draw it nicely. So we have nitrogen there, this nitrogen has hydrogen there, then there is carbon, this carbon has another carbon there, then there's a double bond with oxygen there. So this is the compound. Now we are asked to determine the total number of sigma bonds, the pi bond, and also the hybridization of carbon, hydrogen. Yes, so now let's identify the number of sigma bonds. So the first thing you must do here is to complete the octet rule. The octet rule states that for a certain atom to attain stability, it has to have the total number of valence electron of 8. So let's now complete the octet rule. So we must add hydrogens on carbons so that we complete the octet rule. So we are going to add hydrogen there, like that. On nitrogen will have a lone pair of electrons. On this one, on oxygen, to complete the octet rule, we must add 2 lone pairs. Okay. Then on this carbon, we have hydrogen there. On this carbon also, we had hydrogen. On this carbon, we had hydrogen. On this carbon also, we had hydrogen. So we've completed the octet rule. And on this carbon also, the one which is down, there must be 1 hydrogen. Now let's determine the number of sigma bond. For sigma bond, we said that at each and every bond there is a sigma bond. So whether it's a double bond, a pi bond, as long as it's a bond, there should be a sigma bond. So how are we going to identify a sigma bond? So we start with 1. At this point there's a sigma bond. 2, there's a sigma bond. 3, there's a sigma bond. Even on this double bond, 4, there's a sigma bond. Okay. 5, on this there is a sigma bond. 6, there's a sigma bond. 7 there. 8 there. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we can see that there are 19 sigma bonds. Okay. Now let's identify how many pi bonds do we have. So for pi bond, we need to look at points where there is a double bond or a triple bond. We can see a double bond there, so 1 pi bond. We can see a double bond there, 2. You can see a double bond there, 3. And you can see another double bond. Where is it? There, 4. So there are 4 pi bonds in this compound. So there are 19 sigma bonds and 4 pi bonds. Now the next thing we are asked in this question was to determine the hybridization of carbon, nitrogen, and also oxygen. So the hybridization, let's start with the hybridization for this oxygen here. The hybridization for this oxygen, we can see that there are 3 things attached. So there are 2 lone pairs on oxygen and also a bond there. So since there are 3 things attached, the hybridization will be sp2. Okay, let's look at this carbon here. What is the hybridization of this carbon? So hybridization of carbon, this one, you can see that there are 3 things attached. So the hybridization will be sp2. Let's look at this carbon here. We can see that there are 3 things attached, 1, 2, 3. So the hybridization is sp2. Let's look at this nitrogen here. We can see that nitrogen has 4 things attached. There is this bond 1, 2, this bond attached to hydrogen, and 3, this bond attached to carbon, and a lone pair of electrons. There are 4 things attached on nitrogen. So the hybridization will be sp3. Then let's look at another carbon. We can look at this one. We can see that there are 3 things attached, 1, 2, 3. So the hybridization will be sp2. Which other carbon can we look at? We can talk of this carbon also. This one. This carbon has 1, the bond there, 2, and 3. There are 3 things attached. So the hybridization is sp2. Okay. We can talk of this carbon here. What is the hybridization? So you can see that it has been attached to 4 things: this hydrogen, another hydrogen, another hydrogen, and this carbon. So the hybridization, since it has attached to 4 things, to be sp3. So this is how you can determine the hybridization and also determine the total number of sigma bonds and pi bonds in a certain compound. So we end here with this topic. Thank you for watching. Have a great day. So if you found this to be helpful, don't forget to like, share, subscribe, and comment. Thank you.